Hello everyone, Eddie the Magic Monk here. Today we're going to do some practice questions for queuing. So these questions you don't have to draw a time plot. So just some simple formulas should do the trick. So customers arrive at a shop with one counter at a rate of 30 per hour. Okay, so 30 customers arrive at the shop per hour, and the shop only has one service point. It takes about 3 minutes to serve a customer. What is the inter-arrival time? So I'll give you guys a easy formula for getting inter-arrival time, and that is the time taken divided by the number of customers arriving during this time. So it has taken them 1 hour for 30 customers to arrive. So the time taken is 1 hour divided by the number of customers. So 30 customers arrive in 1 hour. Now 1 hour is not a very easy unit to process. So let's convert that to 60 minutes. Right, because 1 hour is 60 minutes, so it's 60 minutes divided by 30 customers. So that 60 divided by 30 is 2, and because we have minutes divided by customers, it will be 2 minutes per customer. So that's the inter-arrival time, right? Inter-arrival time. It takes 2 minutes for each customer to arrive. Okay, what is the inter-arrival time? Yep. Do you expect the queue to grow? Now, if you guys remember our rule, if the inter-arrival time is greater than service time, right, the queue will shrink, right? Because if you think about it, let's say it takes 1 minute to serve a customer, but customer only arrives once every 2 minutes, then 2 is greater than 1, so the queue will get smaller and smaller. If it was the other way around, if service time, so how long it takes to serve a customer, is greater than inter-arrival time, right? So let's say you take 3 minutes to serve a customer, but customers keep arriving 1 every 2 minutes, then queue will grow. Right, so the service time in this case is 3 minutes. Right, so it's 3 minutes is bigger than 2 minutes, so queue will grow. Queue will grow because service time is bigger than inter-arrival time. Okay, so that is the first question done. I'll give you guys another one right now. Okay, second question. If customers arrive at a rate of 1 every 15 seconds, how many customers do you expect in 2 hours? So 2 hours is equal to 60 minutes times 2, which is equal to 120 minutes. Now, because we're dealing with seconds, we got to times that by 60. So times that by 60, and that is 120 by 60, and that's 7,200 seconds. Okay, so 7,200 seconds. Well, we have 15 seconds for one customer, so divide that by 15, And then the answer is 7200 divided by 15, and the answer is 480. So 480 customers. Alright, 480 customers, because it takes 15 seconds for one customer. There are 7,200 seconds, so 7,200 seconds divided by 15 is 480 customers. Okay, one last question. Question 3. If a server can serve 50 clients per hour, what inter-arrival time is needed to ensure a queue does not form? Alright, well, firstly, let's work out the service time. So the service time is pretty much calculated the same way as inter-arrival time. So it's the time taken to serve some customers divided by the number of customers. Alright, so we got time taken, so 1 hour. It took them 1 hour to serve 50 customers. So 1 hour is 60 minutes to serve 50 customers. So what's that? 60 divided by 50 is 1.2 minutes per customer, which is the answer, right? The service time is 1.2 minutes. Now, what did we say before about the rule? In fact, I'll just scroll up and see it. If the inter-arrival time is bigger than the service time, the queue will shrink. Alright, if you ever forget this rule, just think logically. Okay, if it takes longer for customers to arrive than it takes you to serve them, then obviously it's not, the queue is going to shrink. Right? Until you get that fixed in your head, you probably can't remember this rule. So we basically need an inter-arrival time greater than 1.2 minutes, right? Because it takes you 1.2 minutes to serve a customer. So if customers are arriving at a rate, with an inter-arrival time bigger than 1.2 minutes, then gradually the queue will shrink, and then the queue is never going to grow. Okay, thanks for watching, guys. See you next time.